Hey, we're looking at notes for 9.9 geometric power series. Hey, we need to be able to represent certain types of rational functions as geometric series. Rather than producing the Taylor's rule, we will want to develop the series by manipulating a geometric series, or in some cases using long division. Hey, example 1. First, we'll do a quick review of geometric series. Geometric series are formed by multiplying by a common ratio r. Suppose we start with a sub 1 is 2, and we let r equals 3. What geometric series would we write? First term is 2, our ratio is 3, so we can write it as 2 times 3 to the n, with n starting at 0. And the sum will simply be a sub 1 over 1 minus r. So a sub 1 is 2, r is 3, so it'll simply be 2 over 1 minus 3. Okay. For here, what would it be if a sub 1 is equal to 2 and r equals negative 3? Our a sub 1 is 2, our ratio will be negative 3, and our sum would just be a sub 1 over 1 minus r. So in this case, it'll be 2 over 4, or 1/2. And it says, what if a sub 1 is equal to 1 and r is equal to x? Now here what we have is 1 times x to the n. So we have 1 being the a sub 1, x being the ratio. And if that were the case, our sum would just be 1 over 1 minus x. Hey, example 2. It says find the power series for 1 over 1 minus x. 1 is the dividend. 1 minus x is the divisor. There's a couple ways. One way is we can use the Taylor's rule. Taylor's rule is where we find each of the derivatives and we plug into our Taylor formula, which is the nth derivative value at c over n factorial times x minus c to the n. This will always work. However, it's not going to be the most efficient. Part B, other way what we can do is we can manipulate a geometric series, and we'll look at that. And then finally, doing long division. So find the interval of convergence without using the ratio test, verified by graphing each. So we have 1 over 1 minus x. Now this is in the form of the geometric series. So a sub 1 is simply 1, and then our ratio is just going to be x. So we're basically adding on, each term is being multiplied by that ratio. So we can write it as 1 plus x squared plus ... all the way to x to the n. We can also do this, or find the series, using long division. So we take the divisor on the outside, we take the dividend on the inside, and we go through long division. So 1 times what goes into 1 times 1 times 1 gives us 1. So we take the quotient and we multiply by the divisor. So 1 times 1 minus x gives us 1 minus x. We change the sign of each of the terms and we add terms down. So 1 minus 1 will cancel out. This gives us positive x. We go through this again. 1 minus x times what gives us x. 1 minus x times x gives us x. And so we were just trying to match the first term here, and then we take the divisor, multiply through. So this gives us x minus x squared. So x times 1 is x. X times negative x is negative x squared. Change the sign and we add the terms above. We get x squared. And we keep on doing this, and then we are going to eventually see that this is going to match up with our series. Okay. Now, if we're looking at this rule of sequence, we can see that our interval of convergence using ratio test will just be adding 1 to the n, which is x to the n plus 1 over x to the n, which reduces to be x, and we know x is always less than 1. So therefore, our center of convergence is at 0, our radius is 1. Our possible convergence from -1 to 1, but because we're dealing with geometric series, our interval of convergence will not include the endpoints, so therefore from -1 to 1 with parentheses around the endpoints. All right, example 3, find a power series for 1 over 1 plus x, then find the interval of convergence. Include the general term. Now we know 1 over 1 minus x is 1 plus x squared plus x cubed, and the x is our ratio. Now if we want to adjust this, because we're trying to make this look like our sum formula, a sub 1 over 1 minus r. And if we can make it look like that, the plus x is the issue here. We have to have a minus there. So what we can do is we can make this a minus a negative x to match with our form. And once we do that, then we know their ratio must be negative x. Our a sub 1 must be 1. So each term we're going to keep multiplying by negative x. So therefore we get 1 minus x plus x squared minus x cubed. And we can write our general rule, which is -1 to the n times x to the n. We have alternating series. The terms will alternate signs, x to the n. So we can either write it like this, or we can write it as -x to the n. Example 4, find a power series that represents x over 1 plus x. Now, we can write this by taking out the x. Okay, so if we take out the x, we're going to have x times 1 minus x plus x minus x cubed, because that's simply from the series that we found from above. So we can take what we found from above and then just multiply it by the numerator of x, and when we do that, we distribute the x through, and then we can look at the pattern of these 4 terms to create our general rule of sequence. Example 5. Find a power series for f of x equals 1 minus x squared. Well, we know 1 over 1 minus x gives us this geometric series, or this polynomial power series. So 1 minus x squared will simply be replacing all the x's with x squared, or replacing the x with x squared, so we get x squared, x to the 4th, x to the 6th, so on and so forth. We get x to the 2n.